For the biuret test, we require 1 ml of the protein solution. So we take 1 ml of protein solution in a test tube. Into the protein solution we add 1 ml of 5% sodium hydroxide. Into this we add 2 to 3 drops of 1% copper sulfate solution. On adding the copper sulfate solution, initially it forms a blue colored precipitate on top due to formation of copper hydroxide. On mixing well, we get the violet color of the biuret. The biuret test is used to detect the presence of peptide bonds in proteins. This reaction is named biuret because of the compound NH2CONH2 formed by the condensation of two molecules of urea when heated. The CONH is the peptide linkage in biuret. At least two peptide bonds in the molecule are required for a positive test. Individual amino acids and dipeptides will not answer this test. The copper sulfate is converted to copper hydroxide, which chelates with the peptide linkages in protein to give the color. We should strictly avoid excess addition of copper sulfate. Take 1 ml of the protein solution in a test tube. Add 10 drops of ninhydrin solution into the protein. Heat the contents of the test tube until it boils strongly. Observe the formation of a purple color. All alpha amino acids give purple color with ninhydrin by formation of a complex called Ruhimann's purple. This reaction is often used in the detection of fingerprints in forensic medicine. Take 2 ml of protein solution in a test tube. Into this, add 1 ml of concentrated nitric acid. Heat the solution thoroughly and boil the solution for about 1 minute. Observe the change in color in the test tube. Now, divide the contents of the test tube into two parts and into one half of the solution add 1 ml of 40% sodium hydroxide or until the solution turns alkaline to litmus. I am using a red litmus paper and on turning into alkaline solution it becomes blue. The yellow color formed initially was due to the formation of nitro derivatives of benzene ring system containing amino acids, that are the aromatic amino acids tyrosine and tryptophan. And the color turned orange on adding sodium hydroxide is due to the ionization, and all proteins usually respond to this test. This reaction is also the basis of development of yellow staining on skin by nitric acid. The nitration of phenylalanine under these conditions normally does not take place. Take 1 ml of the protein solution. Add 1 ml of the Millen's reagent, that is mercuric nitrate in nitric acid solution, into it. Boil the contents gently for about 30 seconds. Now add 2 drops of 1% sodium nitrite. The Millen's test or the Coles test is used to detect the presence of tyrosine. The color formed is due to the formation of nitrated mercuric phenolate ion of tyrosine, that is the hydroxyphenyl group of tyrosine has changed into mercuric phenolate. Take 3 ml of the protein solution. Add 2 drops of 40% sodium hydroxide into it. Now add 4 drops of alpha naphthol solution into it. Now add 10 drops of bromine water. Observe the formation of a red PPT. The Sakaguchi test is for the presence of guanidine group, that is the amino acid arginine. Here, instead of sodium hydroxide and bromine water, we can also use 8 to 10 drops of sodium hypobromide. The guanidino groups in arginyl residues of protein react with the alpha naphthol and sodium hypobromide to give the colored complex. Take 1 ml of the protein solution. Add equal volumes of 40% sodium hydroxide into it. Boil the contents for at least 3 minutes. After cooling, add 2 to 3 drops of lead acetate solution. A brown to black colored precipitate is formed. This test is used to detect the presence of sulfur containing amino acid, that is cysteine or cysteine. The organic sulfur in these amino acids are released as inorganic sulfide ions, which form lead sulfide with the lead acetate solution. Methionine does not give this test, as the sulfur group in this amino acid is in thioether linkage, which is difficult to break and not released by treatment with sodium hydroxide. For this test, we initially take 0.5 ml sulfanilic acid in a test tube. Now add 0.5 ml of 0.5% sodium nitrite. Note that it is not nitrate. Add 1 ml of protein into this. After waiting for around 1 minute, add 2 ml of 10% sodium carbonate to make the solution alkaline. Observe the formation of the cherry red color. The Police test is for the imidazole group and phenolic hydroxyl group, that is histidine and tyrosine amino acids. The diazobenzene sulfonic acid reacts with the imidazole ring of histidine or the phenolic hydroxyl group of tyrosine to give the colored products in. Take 1 ml of the protein solution. Add a drop of formaldehyde into it. Then add a drop of mercuric sulfate solution. By holding the test tube slanted, add 1 ml of concentrated sulfuric acid. A violet colored ring appears at the junction of two liquids. The aldehyde test is for the indole nucleus. This test is also known as the Hopkins-Colls test. The indole nucleus is present in the amino acid tryptophan. The mercuric sulfate causes oxidation of the indole group of tryptophan, which condenses with an aldehyde to give the colored complex.